Physics 101. So here we are looking at motion in two dimension. In our previous part, which is part 1, we were looking at motion in one dimension. So specifically here we are going to focus on vectors. So the contents of our lecture series videos, number 1, we are going to look at the components of vectors, that is x component or horizontal component, and y component or vertical component. Then again, we're also going to look at the magnitude of a vector. We're also going to look at how to find the theta. In this case here, they can ask you to find the direction, where we're going to discuss how you can describe the direction of a vector. Okay, then at the end, we're going to look at questions which are exam-based, tutorial sheet questions, as well as college physics questions. So let's start with the components of vectors. So before we start looking at the components of vectors, you and I will notice that a vector is just a physical quantity which has both the magnitude. So what I mean about the magnitude, it just means the size. So let's say we have 20 meters in terms of displacement or change in displacement, or we can have 100 newtons when it comes to weight or the force. Then the same vector quantity, it has also the direction. So you have to understand to say that here the direction can be presented in two ways. It is either you present the direction in form of the theta, or you can present it using the compass. So these are the two ways. Okay, so if they ask you to say find the direction, meaning they're asking you to find what? They're asking you to find the theta. That should come in your mind when they ask you that one. So another thing, before we dive into the components of vectors, we have to understand one thing, that when we talk of vectors, we use the Cartesian plane. You and I, we know to say that this is the y-axis and this is the x-axis. In terms of the sides, you know to say that this is the positive side, the negative side, the positive side, the negative side. But this one is not even important, but you have to know that also. Apart from that one, we need also to look at the quadrants. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So one thing that you have to know here is that in the first quadrant, all are positive, all the ratios are positive. So sine theta is positive, cos theta is also positive, tan theta is also positive. But when it comes to the second quadrant, only sine is positive, the rest are negative. So here we are going to have now cos theta, which is going to be negative, tan theta, which is also going to be negative. Then in the third quadrant, only tan is positive, so tan is positive, then the rest are negative. So meaning to say sine is also going to be negative here, cos is also going to be negative. This is very important, because once we start looking at the components of vectors, we are going to refer to these signs. So take note of that. Then for the fourth quadrant, we know to say that the only ratio which is positive here is cos, then the rest are negative. So we have tan, which is negative, we have sine, which is negative. So these signs are very, very, very important to understand. Now what I'm going to do here is this. Since all ratios in the first quadrant, they are positive, then here we are looking at motion in two dimension. What it means when you say 2D or motion in two dimension, meaning to say an object is moving in two dimension. These dimensions, we have the x dimension and the y dimension. So when an object is moving in two dimension, meaning it is moving in x-axis as well as in the y-axis. So let me just draw a simple illustration here. Let's say we have something like this one here. Okay, we have this triangle here. Now what is happening here is this. If we say this is the resultant of something here, r, which is the resultant of something, or the resultant of a vector, the angle is going to be formed here, isn't it? Which is going to be the theta. So this one, it can describe where the object is moving. Let's say, for example, if someone kicks a ball and then the ball moves like this. If we follow this one as a compass, let me do this. This one is the north, this one is the south, this one is the east, and this one is the west. So in terms of the direction where this ball is moving, it is moving in the northeast direction. That's a direction. But we can also describe it using an angle. So let's say, for example, if this angle here is 30 degrees, meaning to say that is the direction of this resultant vector. That is one thing that you have to know here. Okay, so what I'm going to do here is this. You and I, we know to say that if I write SOHCAHTOA here, SOHCAHTOA, I need to have sine theta as the opposite over hypotenuse, then cos theta as adjacent over hypotenuse. Then the last one, which is tan theta, which is going to be equal to opposite over hypotenuse, isn't it? So what I'm going to do here, I'm going to label now, since this one is the y-axis, so even this one can be y. This is the x-axis, so I can put just x to represent something there. So meaning to say, all the things that we have here, they are all positives. Okay. So what I want here is to come up with the formula, or the formulas that we are going to use to calculate the x component of a vector, or horizontal component of a vector, as well as the y component or vertical component of a vector. Remember, vector is anything that has both magnitude and direction. So I'm going to give you examples of those vectors. For now, let's derive the formulas that you have to know here. So let me remove this 30 here. So what I'm going to do here is this. Since this one is the angle, this angle is going to be opposite to this one here, then hypotenuse to this one. Okay, then it is going to be adjacent to this one. So this is what we are going to have. So let me just use these ratios here, and then we are going to divide now these formulas. Which one is going to suit for the x component, and which one is going to suit for the y component? For now, let me just write it here. So we know to say that sine theta is equal to opposite. So in this case, opposite is y. Okay, then divided by the hypotenuse. In this case, hypotenuse is r. Making y the subject of the formula, y is going to be equal to the resultant vector, then sine theta. So this means to say, if you want to find the y component, you have to use this one here. This is the formula that you have to use. But this formula is only applicable when the angle is in the first quadrant. Okay, when the angle is in the first quadrant. Another thing that you have to understand here, I'm going to mention, stay tuned, to say, here we have cos theta, which is equal to adjacent over hypotenuse. So we know to say that cos theta is going to be equal to adjacent is x in this case. Then hypotenuse is r. Making x the subject of the formula, x is going to be equal to r, then cos theta. So meaning to say, if you want to find the x component, you have to use this formula here. You have to use this formula here. So r being the resultant vector, it can be anything. When I said it can be anything, you have to talk about now the examples of vectors. For example, we have force as a vector quantity. We also have weight as a vector quantity. We also have displacement as a vector quantity. Apart from displacement, we also have velocity as a vector quantity. We also have acceleration as a vector quantity, and so on. So these are the only ones which I'm going to talk about in this lecture video. So stay tuned. So meaning to say, where I'm putting R, if I'm dealing with forces, let me repeat. When you are dealing with forces, and you want to find, let's say, the y component of the force, what are you supposed to do? This is y. So we are going to write Fy to represent the y component of the force vector. And this is going to be equal to, since this one is r, the resultant vector, instead of using r, you are going to use now capital letter F to represent now the resultant force. Then you say sine theta. Similarly, when you talk of weight, you say weight, or Wy, which is going to be equal to W, then sine theta. When you talk of acceleration, the same thing, you write capital letter M, then Y, which is going to be equal to capital letter A, then sine theta, and so on. Then when you talk of velocity, it's going to be Vy, which is going to be equal to V, then sine theta, and so on, whichever vector that you're looking at. Okay, so I've explained that. So you need to keep in mind. And remember, all these things that we have discussed about, they are positives, isn't it? There is nothing like putting a negative on these formulas. Because when we go into the second quadrant, the formulas are going to be different. That is one thing that you have to know, depending on the signs which I've talked about here. Okay? Now we are remaining with one ratio, which is tan. So we know to say that tan theta is equal to opposite over adjacent. So in this case, the opposite is y, then the adjacent is x. So we can say tan theta is going to be equal to y divided by x. So this is the formula that you are going to use to find the direction or the theta. So if they ask you to find the direction or theta, you have to use this formula. How do you use it? That's very simple. You make tan the inverse. You make tan the inverse. So how do you make tan the inverse? Theta is going to be equal to tan inverse. And then you say y divided by x. Or if you don't want to use this one here, you can also use this one, tan inverse, then open bracket. What is y? If you look at these formulas, y is equal to what? Resultant vector sine theta. Then x is equal to what? Resultant vector cos theta. So it can be also equal to resultant vector sine theta, resultant vector cos theta. As a result, you know to say that resultant vector and resultant vector, they can cancel each other. So if they cancel each other, let me just move that one. If they cancel each other, this is what we are going to have. Okay? You can also use this formula. It is also applicable. So meaning to say, if you want to find the x component or horizontal component, which formula is supposed to use? This one is for x component. So for x component, just depend on the vector that you're dealing with. So let me just use x, which is going to be equal to r, the resultant vector, then cos theta. For the y component, y, which is going to be equal to r, resultant vector, then sine theta. Now, another thing that you have to know here, since you have understood where we are getting these now, formulas, let me also include how to find theta. So theta is going to be equal to tan inverse y over x. Even here the same thing. Theta is going to be equal to tan inverse then y over x. The same formula. Now, let's talk about how to measure an angle as we go into the second quadrant. So how do you measure the angle? So always remember to say the angle, we measure it starting from the positive x-axis. Positive x-axis is this one, and then negative x-axis is this one. What I mean is this. Let's say you are having a triangle somewhere here. This one is just a rough sketch. You're having a triangle somewhere here, and this triangle is having a theta, let's say, of 30 degrees. This angle is not the actual angle, it is the reference angle. The actual angle should start from the positive x-axis to where the angle is being formed. So in this case, you need to start from positive x-axis and then you go up to this point here. That's when you're going to use the same formula which I've given you. Those formulas like for the x component is equal to resultant, then cos theta. For the y component, resultant, then sine theta. So meaning to say this is the straight line, and it is 180. So you add 180 plus 8. Then I guess you're going to get to 10 degrees. Then you can use these formulas here. Now let's say, for example, if you want to use the angles or the angle that you have been given in the question, what are you supposed to do? That is now what we are going to talk about to the second quadrant. So for the second quadrant, let me just draw a rough sketch of the triangle. So I'm not going to rub these ratios here because they are very important, the signs, especially the signs. Okay. So what I'm going to do here is, this one is the theta. So one thing that you have to understand here is that we have two angles. We have two types of angles when we are dealing with vectors. We have the actual angle. So you need to know where the actual angle starts from. We also have the reference angle. Okay, the reference angle. The reference angle as well as the actual angle. So for the actual angle, always it starts from the positive x-axis and goes anti-clockwise. For the reference angle, let me give you an example like this one here. It is not starting from positive x-axis. It can start from anywhere, but not from the positive x-axis. That one is the reference angle. For example, if this is 45 degrees, 45 degrees is the reference angle, but the actual angle, it has to start from positive x-axis up to where the triangle is being formed. So in this case, to find the actual angle here, just very easy. Straight line adds up to 180. 180 minus 45, that is 135. So 135 is the actual angle. So the actual angle is 135 degrees. Then the reference angle is 45 degrees. That's a difference that you need to understand there. So in terms of the formulas to use, like this one here for the x component, and this one for the y component. You need to be very, very careful when to use them. You can only use these formulas when the angle that you have been given is starting from the positive x-axis. Let me repeat it because you are going to forget, I know. But remember to say, you can only use these formulas to calculate whatever components that you are calculating when the angle is starting from the positive x-axis. So how do you know that the angle is starting from the positive x-axis? You need to look at the angle where it is. Is it in the second quadrant? Is it in the third quadrant? How do you know? The range. So if I give you, let's say for example I give you 45, but just depend to the question, how the question is being phrased. Because 45, it can be in the first quadrant, it can be also in the second quadrant, depending on the description of the question. Because they can say, let's say the player kicked the ball and the ball moved to the northwest at an angle of, let's say, 45 degrees. Northwest, if you draw the compass, where is northwest? This is north and this is west. So meaning to say the angle is 45. You can't say that starting from here up to here, this one is 45. No. Meaning to say that 45 is the reference angle. That's the way we assume things. Then when they said the player kicked the ball at an angle of 45 degrees northeast. So this is east. Meaning to say that angle is in the first quadrant. So just depend on the description. So these two formulas, you can only use them when the angle is starting from the positive x-axis. But if you want to use the reference angle, you need to look at these signs here. So sine is positive, cos is negative, tan is negative. So we are going to make some changes here, but sine is just going to remain the same because it is positive. Even if I put positive here, it's just going to remain the same. But for the x component, x is going to be equal to, then here we are going to have a negative, then resultant vector, then cos theta. So what I mean here is this. Let's try to find the x component and the y component using the actual angle and using the reference angle. Then see what I'm talking about. So let me start with the actual angle, which is 135. So for the actual angle, you need to use this x component. Let's say, for example, this is 20 newtons as the force. So Fx is going to be equal to F, then cos theta. So in this case, we have 20 newtons, and then cos 135 degrees. So let me just do the computation for that one. So we have 20, and then cos 135. Okay. So here, I'm getting negative. Okay, let me just do again. Maybe I can make a mistake there. So I have 20 newtons, and then cos 135. So I'm having negative 14.14 newtons. So this makes sense because you remember to say this is the negative side of x. This is the positive side of x. So there is nowhere to say on the negative side of x you get a positive answer, meaning to say your answer is wrong. You have to understand that. What about y? For this side, y is positive. For this side, y is negative. Even for this side, y is negative. As simple as that. What about the y component? So Fy is going to be equal to 20 newtons, then sine 135. So let me also do that one. So 20 sine 135. So here I'm getting positive 14.14 newtons as my final answer. This makes sense because this is the positive side of y. Now, if you want to use the reference angle, if you have been given the angle as the reference, you're not going to specify to say this is the reference angle. It is up to you to come up with a free body diagram and plot. Plotting is just very simple. Use the compass according to the description of the question. Okay? So for the y component, it's just going to remain the same. This is because it is positive. Okay? Just going to remain the same because it is positive. So that is positive 14.14 newtons. For the x component, there are going to be a change. Instead of us putting, let me not even put 135. Let me put 45. It's just going to be the same. So if you punch on the calculator, you're going to get the same answer. Then here, instead of us putting a positive, we're going to put a negative. Why? Because cos is negative in the second quadrant. Cos is negative in the second quadrant. That is what it means. Then 45. So So let me just do the computation. So we have 20, which is negative 20, then cos 45. So I'm getting negative 14.14 newtons. So as you can see, they are just the same. So what I can encourage you here is that the formulas depends on the description of the question. If the angle is 1, the actual angle, or the angle is the difference angle. So let's just do a recap. What formulas are you supposed to use when you have been given the actual angle for you to find the x component and the y component? So for the x component, you need to use this. For the y component, you need to use this. That is when the angle is actual angle. Then when the angle is a difference, which formulas are you supposed to use? So the formulas depends on the angle, or where the angle is formed. Let me repeat. The formula depends on where the angle is being formed. Is it in the second quadrant? Is it in the fourth quadrant? Is it in the third quadrant? It depends on where it is formed. So let's say, for example, if the angle is formed in the third quadrant, okay, in the third quadrant, and let's say this is 30 degrees as the difference angle. You don't want to use the actual angle starting from here and then you end here. No, you don't want to use that one, isn't it? So in terms of the x component and the y component, remember sine is negative, cos is negative. So meaning to say x component is going to be equal to negative the resultant vector, then cos theta. Y is going to be equal to negative resultant vector sine theta, depending on the quadrant. For the fourth quadrant, x is going to be equal to, since cos is positive, so we are going to have this. Since sine is negative, we are going to have this. This is what it means. Then nevertheless, you have to understand to say, if you want to find the direction, meaning to say they are asking you to find theta, so theta is going to be equal to tan inverse, then y divided by x. So that is one thing that you have to know. Now, let's try to look at how to find the magnitude of a vector. So how do you find the magnitude of the vector? So the magnitude of the vector, it can be any vector. Let's say, for example, you want to find the magnitude of velocity. Okay? So you have to use the formula for Pythagoras theorem. So in this case, that is the root of velocity x component squared, then plus velocity y component squared. This is the formula to use. But it just depends on the vector that you're dealing with. So let me just use r in general. And this is going to be equal to rx squared, then plus ry squared. So that when you're dealing with forces, you're going to replace force here, which is F. And this is going to be equal to the resultant, let me say the x component for the force squared, then the y component for the force squared. This is the summation. So if you're dealing with different or many forces, you have to add the x components of those vectors. What I mean here is this. If the question is involving two or more vectors, let's say, for example, we have A, which is having, let's say, 20 newtons as the x component. We also have B, which is having, let's say, the x component to be 30. Then they tell you to find the resultant vector, and so on. So in this case, I mean, you also have AY, which can be less than negative 30 newtons. Then A or PY, which can be equal to, let's say, positive 40 newtons. Then they tell you to find the resultant vector. So you have to find the sum of all the x components, you add them. You also add the sum of all the y components. You add them together, and then you find the resultant vector. For example, to find the resultant vector of this one, I need to add the 20 plus 30, then I'm going to get 50. So that is 50 now squared. So you have to show first. You have to show. You say AX plus BX is going to be equal to 20 newtons plus 30 newtons. And this is going to give me 50.0 newtons. Then again, for the y component, you do the same thing like this. Then you get this 50 newtons, you put it there because it is representing the summation of all the x components. Then for this one, I guess it's just going to give me 10, then squared. Then you do the computation. So let me just help you. So this one is 50 squared, that is 2,500. So 2,500, 10 squared, that is 100. So plus 100. That is 2,600. Then I need to find the square root of 2,600. Right? Square root of 2,600. So here I'm getting 50.99. Then in this case it's going to be newtons. So this is how you're supposed to find the resultant vector. Now let's try to look at this example. In this example, the goal is to find the vector components given a magnitude and direction and vice versa. So the problem, here we have been given a free body diagram. So in the test or in an exam, maybe they are not going to give you the free body diagram. You have to draw for yourself. So for question A is saying find the horizontal component or the horizontal and vertical components of the D, which is 100 meters displacement. So here we are dealing with a vector which is displacement, which is measured in meters, of a superhero who flies from the top of a tall building along the path shown in figure 3.11a. So what are we looking at here? We are looking at, we want to find the x component. We want also to find the y component. But before we find those, we need to come up with the formulas that we are going to use. So the formulas depend on where the angle is being formed. Is it the actual angle or the reference angle? So according to what you can see here, is this one the actual angle? Is this one the actual angle? It's not the actual angle because I said the actual angle starts from the positive x-axis and then goes like that. So the actual angle, it has to start from here, then ends here. So meaning to say this 30 is not the actual angle, it is the reference angle. So if you, just up to you. If you want to use 30 direct or you want to find the actual angle. You know to say that a circle adds up to 360. So for us to find the actual angle here, we need to say 360 minus 30. Then I'm going to get 330 as the actual angle. So to find the x component here, I need to say x. Okay, let me not use x first, since we're talking about displacement. So let me use dx, which is going to be equal to d, then cos theta. So in this case, the distance there is 100 meters. If you want, you can just write it like the way they have written here. That's okay. Then cos. So here I'm using the actual angle, which is 330 degrees. Then let's see what I'm going to get. So we have 100, then cos 330. So I'm getting positive 86.6. And this makes sense because this is the positive side of x. So you have to get a positive answer. Then for the y component, y or dy is going to be equal to d, then sine theta. So in this case, I have 100 here, meters, then sine 130. Let me not say 130, but 330. So we have 100, then sine 330. So here I'm going to get negative 50.0 meters. This makes sense because this is the negative side of y-axis. If you draw the Cartesian plane here, this is the negative side. So it can be either this side or this side. And this is the positive side of y. It can be this side or this side. So that is one thing that you have to know here. Okay, so we have used the actual angle to find the components. That is the x component and the y component. Now let's use the same method that we have been given to find the x component as well as the y component. So in which quadrant first is this quadrant? This quadrant is the fourth quadrant. So in terms of the sign for cos is positive. Then for sine is negative. Right? That is what it says. So in terms of the formula, the only formula which is going to have a negative is the one for finding the y component. So you can say x component. Let me just write x comp, and this one is going to be equal to. So we have dx, which is going to be equal to d, then cos theta. This can be positive, so we have 100 meters, then cos 30 degrees. Then this one is going to give me 86.6 meters, and this is positive. Then if you compare, we are getting the same answers. For the y component, or y comp, y or dy is going to be equal to d. Remember, here we are going to include a negative. The reason is just very simple because sine is negative in the fourth quadrant. So this is sine theta. So we have negative 100 meters, then sine 30. So sine 30 is half. What is the half of negative 50 of negative 100? That is negative 50. So negative 50.0 meters. So as you can see, we're just getting the same answers. So it's just up to you to decide which formula you want to use. So you need to understand, vectors is the foundation in physics 101. So whatever you're going to discuss further, we're going to refer to the vectors. All right. Now, let's try to answer question B. So for question B, it is saying, suppose instead the superhero laps in the other direction along a displacement vector B to the top of a flagpole, where the displacement components are given by x, or bx is equal to negative 25 and by is equal to 10 meters. Find the magnitude and direction of the displacement vector. So you see where it is pointing, isn't it? So the angle is this one. But the angle that we're going to find here is not going to be the actual angle. Why? Because it is not starting from the positive x-axis. If I complete this one, this is the x-axis. So the angle, it has to start from here and ends up to this point. So let's start by finding the magnitude. We are looking at displacement as the magnitude. So we need to say dx squared, then dy squared. So I've been given the x component, we've also been given the y component. So very simple to find. So we have negative 25 squared, 10 squared. So if you want, you can also include the meters. Okay, you can include the meters. So let me start with 25. So 25 squared, I'm getting 625. Then 10 squared, that is 100. So I can add plus 100. I'm getting 725. Let me use this part. Okay, so square root of 725. So root of 725. So I'm getting 26.9 meters. So this is how you're supposed to answer that one. So that one is the magnitude. Now, this question continues by saying we need to find also the direction of the displacement. Remember, the direction, it can be described in two ways depending on the question. So this question is asking us to find the theta. How do you find theta? Theta is going to be equal to tan inverse y minus x. This means to say that is the y component divided by the x component. So the y component is negative 25. Then the x component is what? Is 10. So let me just do the computation for that one. So we have 25, which is negative 25, divided by 10. I'm getting 2.5. Okay. Then inverse, or tan inverse, 2.5. Okay. So this one is going to give me 68, which is going to be negative 68.2 degrees. Now this negative 68.2 degrees doesn't mean to say the negative, the angle is negative. That negative, what is indicating there is that the angle there is not the actual angle. It's a difference angle. Actually, for the third quadrant, then it has to be positive, isn't it? So that one, the one that we have found here, is not the actual angle. It's a reference angle which is to be there. So this one can be also be written as 68.2 degrees. But this one is also not the actual angle. For us to find the actual angle, we need to start from the positive x-axis and end here. So we notice that this is 180. So we are going to add now. Plus 180. Plus 180. So if I add plus 180, what I mean is, let me do this, plus 180 degrees, then I'm going to get 248 degrees. Then this is going to be our final answer. So this is how you're supposed to handle such questions. Now, in the second part, we are going to look at projectile motion. So make sure to register for more videos.